Hello and good afternoon friends, welcome to the CEC-UGC live lecture. For all the students of chemistry, we would like to tell you all that today we are going to talk on a very interesting topic, and I would say not only for the chemistry students but for the students from the other fields, other departments also would enjoy today's lecture, because today we are going to talk on chemistry in everyday life. So dear friends, I believe now you must be curious to know what are we going to cover under this topic. So dear friends, I would like to tell you all that for this very discussion on the topic chemistry in everyday life, we have once again with us in our studios Dr. Amit Kumar. Dr. Amit Kumar is a senior assistant professor in Department of Chemistry, Dal Singh College, University of Delhi. As you all know that Dr. Amit Kumar keeps on visiting us, and through live EduSet lectures he delivers knowledge. He exchanges information so that it becomes easier for you to get in-depth knowledge on different areas of chemistry. So first of all, we would like to welcome our guest Dr. Amit Kumar, and under his able guidance we would be knowing how chemistry is useful in day-to-day life. Hello sir, welcome to the EduSet lecture.
Hello, thank you so much Kitika for nice words of introduction towards the topic as well as me. Dear friends, today, as is being introduced, today we are going to talk about chemistry in everyday life. This topic in itself looks to be very interesting in a way that it helps us to understand the basic principles of chemistry. Not only that, it helps us to know whether the basic principles of chemistry we are learning in our normal usual BSc honors chemistry or any other BSc course, what way and on what is the basis, what way these elementary tidbits of knowledge which can be used in our explanation of normal everyday life. So with that objective we have planned this today's lecture. So let's see what we need to say in this lecture. First of all, I would say that in all life forms, if we talk about humans, if we talk about all mammals or any other life forms, whether it is aquatic or whether it is mammalian which lives on earth or wherever it is, all life forms basically depend on the chemistry subject itself, because all the sustainable life processes greatly depends on the chemical transformations which continuously goes on within an organism, and therefore all life forms on this earth therefore depends greatly on chemistry. And therefore our understanding of fundamental nature of our world is grounded in chemistry. That is what we can say. So having said this, now let us have a look at this picture. I would like to say we have this picture. In this picture we have shown there are 4 different ice creams to be relished. The 2 ones are the ones which usually these days are available in the form of ice cream bricks, and 2 are conventional ones. This one is conventional, which is called kulfi, and this one is also conventional ice cream which is also called kulfi. You must have noticed what we need to discuss over here is one physical observation. You must have noticed that when we buy a kulfi and we try to relish it, it is very hard. And it is very hard, and it takes time for us to lick it, because it gets liquefied over a period of time, because it is very hard. And if you will notice that its temperature, surface temperature would also be lower compared to the modern present day ice cream brick. And you would have also noticed that when you buy an ice cream brick, it is not that very hard as is the conventional ice cream which is called kulfi. So basically there is no chemistry in being hard or in being not that hard of the 2 types of ice creams, but the fact of matter is we must notice that when we buy these modern ice creams bricks, we get from a vendor who store these ice cream bricks in a freezer which is electrically operated. So it will certainly lower its temperature, and that is how some milky batter gets solidified and gives you a form of ice cream to be relished. So lesser the temperature of the storage compartment, and harder it will be the ice cream brick. That's the simple logic we can draw out of this. So it means conventional, compared to this, when we compare this modern ice cream brick vendor with that of a conventional ice cream vendor, that is Kulfi, if you would have noticed, he does not have any fridge, any electrical or equipment to operate with. He only has a wooden case which is actually insulated, and there is no electricity which has been given, and yet he produces very low temperature there in the bath, which is being present in the wooden case, and where he solidifies the milky batter to obtain these conventional ice creams called kulfi. So it is for sure if these that if these classical ice creams or conventional ice creams, the kulfi, which are harder ones, it certainly indicates that they are present at very low temperature. That is why they are more hard. So the question arises, the main observation which we should draw out of this observation is that the electrically operated freezers have higher temperature compared to a conventional ice cream vendor who did not have even the electricity to operate his business. So what he is doing, how he produces such low temperature, that is what is our objective. If you would have noticed, what he does is he make a wooden case, and he also introduces a layer of thermocol which insulates the wooden case, and within which what he tried to put in, a lot of crushed ice he tried to put in, and he mixes a lot of sodium chloride, or to say common salt, and tries to add little bit of water, and onto this mixture he just let the iron stand to rest, and on the iron stand he can put in iron blocks, and on the iron blocks he just pours in the milking liquid, which actually gets solidified to produce the conventional ice cream called kulfi. So now question arises, the iron block which is being present inside this case, wooden case, in which there are two components basically. One is water, which is present in two different phases. One is solid phase, the other is liquid phase, and also there is solid sodium chloride. So basically what happens, ice temperature is of the order of is exactly of 0 degrees Celsius. When you try to put in lot of salt in it, and then when you try to put in a little bit of water to it also, then what happens, there are basically three phases. There are basically three phases and two components. So in order to achieve a composition which is corresponding to that of the saturation solubility, the sodium chloride tried to dissolve in water first. When it tried to dissolve, in doing so, it because dissolution, the enthalpy of solution for dissolution of sodium chloride is an endothermic process, it decreases the temperature further. Not only that, when it exhausts all the added water, then what it tried to do is try to liquefy the ice, and then the liquefied water which gets formed, because of the liquefaction of solid water, that is ice, then what happens, in this water the sodium chloride again gets dissolved and it forms a solution. So again there is temperature decrease. So temperature gets decreased within the wooden case because of two things. One, there is ice which is present at 0 degrees Celsius. Other thing, there occurs dissolution of sodium chloride in liquid water, which also decreases temperature. Then there is one more thing, that is phase transition of ice to that of liquid water, and all these transformations are occurring within the wooden case, which is insulated from the surrounding by virtue of an adiabatic wall, by introducing a thermocol casing inside. So therefore what actually happens is that all the heat which is required for phase transformation of ice to liquid water, or dissolution process of sodium chloride in water, for both these processes they require heat, and heat cannot come from outside or from surrounding, because we have insulated the system from that of surrounding. So therefore from where the heat will come? whatever the thermal energy which is being present within the system, that is called hot case, the heat will come out of that thermal energy only, and when that thermal energy is basically is a result of is a part of internal energy, and when that internal energy gets decreased or is consumed in carrying out these two processes, then the energy of the system further decreases, and this energy of the system when decreases, it leads to a decrease in temperature. And there is a fixed composition that is called eutectic composition, which you will learn a great deal about in the knowledge called phase equilibria chapter in your BSc chemistry classes, where you will get to learn in the phase diagrams that there is a eutectic composition, there is a composition of water and or proportion of water and sodium chloride, for which there would be a minimum melting point of the mixture. So therefore, when you reach to that composition of sodium chloride and water, you can produce the mixture with least melting point, and hence the whole system, or in other words the ice cream vendor would have its temperature in the system is that can go as low as up to minus 21 degrees Celsius. So you can now imagine a modern electrically operated ice cream vendor has a refrigerator whose temperature can go only up to about 0 degree Celsius, 1 or 2 degree plus minus. But on the other hand, a conventional ice cream vendor who would be having his system, the ice cream vending wooden case being maintained at a much low temperature, that is of the order of which can go even up to minus 21 degrees Celsius. So there is a marked difference between the between the temperature of conventional ice cream vendor and the modern day ice cream vendor, which is having his refrigerator electrically operated. So the conventional ice cream vendor, which the method which he chooses to make his system or to make his vending system for the ice creams at such low temperatures, the method is basically based on the creation of freezing mixtures. So there is one such freezing mixture, that is of water and sodium chloride, as I said, for which you can go up to minus 21 degrees Celsius of temperature. So if you talk about, there are other freezing mixtures are also available for just using your usual chemistry laboratory chemicals. You can also go up to minus 78 degrees Celsius of temperature also. So from this observation, what we learn is that, just a simple observation, that we just need to compare in your common everyday life. Take example of ice cream vending shop of a modern day or a conventional kulfi wala, and then you can compare the temperatures, the solidity of the ice cream. That can be explained on the basis of the knowledge which lies in phase diagrams. So that way you can understand what way the physical chemistry principles under the topic phase diagrams, how they explain the solidity of the texture of the two different kinds of ice creams, or the temperature either. Right. Having said so, now let me take another example. For example, we consider the water in rivers. The question arises, from where the water comes in rivers, because ice has temperature of 0 degree Celsius at atmospheric pressure, and with change in pressure, how much change in melting temperature occurs, that is also another question. And when it comes to glaciers ice, they are maintained at a height much greater than that of the sea level. So altitude is much higher. So at such low pressure, as we elevate up high in the sky, the pressure being exerted, atmospheric pressure gets decreased. So we must understand what changes to the melting point occurs of any substance, or for that matter water itself, in order to explain the phenomenon of having water in rivers, which comes from melting of glaciers. So basically, How nature does it? We should understand it. From the glaciers, water comes. This observation can also be explained using the knowledge of phase diagrams. We try to emphasize on phase diagram on one component system, especially of water. What we get to learn from the phase diagram is that when we exert external pressure on the surface of ice, the melting temperature of ice gets decreased. So, basically what happens is that at glaciers, due to the weathering of rocks, this process exerts pressure on the surface of ice on the glaciers, and that is how this pressure which gets exerted decreases the melting temperature of the ice being maintained at glaciers. So, therefore, even at low temperature surface melting can be observed there, and due to this surface melting the water goes deep down and finally comes to the rivers. There is another observation. You must have noticed that in places like snow covered mountains, there are skating is being observed and is being observed as a sport. The question arises, ice is a solid substance, and on any solid it is difficult to observe a skate unless there is some lubrication. So, question arises, how come what the skater's blade does to bring about skating on surface of ice, which is a solid. So, basically here again we can make use of same knowledge that when pressure by virtue of the skater's blade, the blade of skaters gets applied on the surface of ice, then due to this exerted external pressure, high external pressure, surface melting as a phenomenon is observed again on the surface of ice, and which leads to liquefaction of the surface, and therefore which adds to lubrication of the surface too. And due to this lubrication, what we do observe is that we observe skating by virtue of the skater's blade of a skater. Right. So, now here there is, apart from this physical chemistry, we can also think of water is only substance on which when you apply external pressure its melting point gets decreased. Why so? Because we all know that water is one substance which is in a way that solid water, that is ice, is less dense as compared to water in liquid form. So, ice floats on surface of liquid water, and this results because of enormous hydrogen bonding between water molecules in water. And because of this open structure of hydrogen bonding in solid phase, what happens is that when we apply external pressure, the extent of hydrogen bonding to decreases, some of the hydrogen bonds undergo a breakage, and therefore because of this breakage in hydrogen bonds, the melting point gets decreased, and as a result what we observe is surface melting when we apply external pressure on the surface of ice, and this is the result that we observe skating. So, having discussed this, let us switch on our another very good observation. We must have noticed in our kitchens there are when we chop onions, cut onions or chop onions, then what we observe is that the tears comes in our eyes. If you would have noticed your mothers, your sisters too, working in the kitchen, chopping the onions, they would also be having tears in their eyes. So, basically the question arises, how come the tear comes in the eyes due to the chopping of onions? There is a huge and mammoth chemistry behind this. So, with the objective to discuss that chemistry, let us focus on what goes on when we chop an onion. But before we go to discuss that, we must understand what are amino acids. We all know there are amino acids compounds which have amine and carboxylic groups in the compound. So, there is one amino acid which is cysteine also. So, in cysteine there are derivatives of cysteine which we have considered, that cysteine sulfoxide which are actually present in all the allium species like onion, garlic, leek. There are different sulfoxides are present. and therefore cysteine sulfoxides are the important compounds which are present in all these allium species. So, what is basically a cysteine sulfoxide? Just have a look at this. RSO CH2, CH2, NH2, COOH. This compound, if you observe this, you can say that this is cysteine sulfoxide. Now, this R can vary. This R can be a methyl group, can be a propyl group, can be a phenyl group, or can also be a isopropanol group too. So, therefore, depending upon this variation in alkyl group, that is whether it is methyl, ethyl, propyl, 1-propenyl or 2-propenyl group, there are this R cysteine sulfoxides are named differently. Their trivial names, when methyl group is there, their trivial name is methine, and when ethyl group is there, the trivial name is ethene, and propyl when is there, so propene, PROPYIN, and when 1-propenyl is there, isoalene, and when 2-propenyl group is there is called 2-alene. So, or simply to say alene. So, these are the respective names. So, depending upon this variation of alkyl group substitution, there are different cysteine sulfoxides which are present in different allium species like onion, like garlic, like leek. So, their characteristic smell of these allium species are due to these cysteine sulfoxides basically. So, basically what happens is that when we peel an onion, when we peel an onion and chop it, the cells of which are present in the onion tissues gets chopped. So, when there is rupture of cells which occurs, then what occurs is there occurs the mixing of an enzyme called alliinase with that of these cysteine sulfoxides which are present inside the cell. So, therefore, when this enzyme alliinase do combine with cysteine sulfoxide which is present in these allium species, then it leads to formation of cysteine sulfanic acids in addition to pyruvate and ammonia being other products to it. So, you can see how big chemistry which goes on just using the catalysis by virtue of the introduction of this enzyme which is present even in the onion itself. Only thing is that when you peel and chop the onion, the enzyme and the compound get mixed, and this enzyme then catalyzes this reaction of the cysteine sulfoxide to form actually the sulfanic acid. Here in onion, the major sulfoxide is 1-propenyl cysteine sulfoxide, this compound basically, where R is 1-propenyl group. So, therefore, when then it leads to form 1-propenyl sulfanic acid, which is this compound, and now you can see and notice the carboxylic group is now, this whole moiety is being changed and it has made to such a big transformation. Sulfanic acid has been formed. So, in order to carry out such a organic chemical reaction in laboratory, you can think of what kind of mammoth physical and chemical exercise, chemical reaction system we need. But here in just chopping of onion and peeling of onion, this exercise gets done of its own. So, simply the enzyme does the job and catalyzes this reaction, and when sulfanic acid is formed, let us see what happens to sulfanic acid. Basically, when we chop an onion and due to this reaction sulfanic acid gets formed, then 1-propenyl sulfanic acid comes in contact with another enzyme which is also present in content of the same species. So, therefore, that is called lacrimatory factor synthase, that is another enzyme which is present. So, therefore, is the sulfanic acid which gets formed gets transformed to propanethiol S oxide, which is here is this compound. So, now propanethiol S oxide, which is this compound. So, now you can also see another thing, that in this second step how mammoth the exercise is, how much is the chemical transformation, how much is the transformation of functional groups, thiol groups gets converted to this S oxide group. So, in order to bring about this much chemistry in laboratory, you can just think of, you cannot even think of how much mammoth chemical exercise, chemical reaction system we need to bring about this transformation. But in cutting and chopping of onion, this exercise gets done so easily with the help of catalyst, that is the enzyme, and there are two enzymes are involved, and this two-step process, what you get is propanethiol S oxide. Now, this propanethiol S oxide is a volatile sulfur compound. Volatile sulfur compound means it has appreciable vapor pressure. It gets volatilizes and gets evaporated in order to form vapors, and these vapors just do wafts towards our eyes, and when they comes in contact with our eyes, they combine with the water. And when they combine with water, what they do form is surprising. What they do form is sulfuric acid. So, it means when during the chopping and peeling of onion, sulfuric acid gets formed in our eyes, that too at very low concentrations, which may not actually harm our eyes, but the fact of matter is what this sulfuric acid does, it actually activates the lacrimatory glands in our eyes, and those lacrimatory glands then release water, then release tears, and then when tears comes, then this sulfuric acid gets washed, and that is how you can see the mammoth chemistry which is actually involved in cutting and chopping of onions. First is there are sulfoxide, cysteine sulfoxide compounds which are present in all the allium species. They gets actually in combination with alliinase enzyme which is present within the allium species itself, they do combine to form sulfanic acids, and sulfanic acid then combines another way gets catalyzed with the help of another enzymes, that is lacrimatory factor synthase, to form this propanethiol S oxide, which actually bring about a reaction with water in our eyes when our eyes gets exposed due to its volatile vapors, and then it forms sulfuric acid, and that is how it activates the lacrimatory glands and how tear comes. And you can see and appreciate the beautiful and mammoth chemistry just behind a simple kitchen exercise, that is chopping and peeling of onion and all other allium species. Thank you. Right, in this section we will learn about the chemistry which gets operated in our performance of our oral health, exercises of oral health, that is when we carry out toothbrush every day in the morning, and we will see what is the chemistry and chemical composition in our toothpastes and how they do actually work. Right. So, we should first of all understand what is there in our toothpaste. In our toothpaste, the first compound which comes into account is calcium carbonate, which is the first compound. Basically, if you will notice this, from where this calcium carbonate comes, you will fear of toothpaste even, the way the industry does it. Just have a look what other things are there. So, calcium carbonate acts as abrasive to remove plaque from the teeth, basically that is why calcium carbonate is added. Then sorbitol is added. Sorbitol is added to prevent loss of water. So, whatever content solid which has been there and a paste is being formed due to addition of liquid, sorbitol is added so that the liquid does not get vaporizes, rather it remains and allows the toothpaste to remain in that pasty form. It should not get solidified. In addition to sorbitol, what is basically another, the most important active constituent in toothpaste, if you will notice, what is that, you will surprise. There is another compound that is called a detergent which is added. A detergent is added in the toothpaste, you must understand it. What the detergent does it? It cleanses obviously. So, sodium lauryl sulfate also is present, which acts as a detergent to loosen plaque. So, calcium carbonate is there to remove plaque, and sorbitol is there to let the toothpaste to remain in that semi-solid form, should not get solidify, should remain in the paste form, and sodium lauryl sulfate as a detergent is being added, sulfonate, sorry, sodium lauryl sulfonate is being added, sulfate is being added as the detergent in order to loosen the plaque. There is third component which has also been added, that is sodium fluorophosphate. Sodium fluorophosphate basically it prevents formation of cavities by strengthening tooth enamel with fluoride. If you notice, the oral health agencies in US does not grant their node to any toothpaste manufacturer unless they are sure that it has fluoride content. That is, it should have sodium fluorophosphate, which prevents formation of cavities by strengthening tooth enamel with fluoride. And you must note that it is not that sodium fluorophosphate is that essential for, it's essential for prevention for formation of cavities, but there is a problem also with it, with this compound also. If it is swallowed and if it goes to the intestine, then it can lead to a harm to our mucous membrane, the epithelial cell in the intestines too. So, we should be aware of the fact, and we, while carrying out the oral health exercises every day in the morning, we should make sure that the toothpaste which we are doing, the content should not go inside our stomach there. Right. Having said this, there are so many other things. These three things are important: calcium carbonate, which acts as abrasive to remove plaque. Then there is detergent which is added to loosen the plaque, and then there is sodium fluorophosphate which has been added, that is just to prevent the tooth decay from the cavities, that is just by virtue of the fluoride. So, therefore, these three are important contents. Their way sorbitol is added. Sorbitol is added to let the toothpaste to remain in the semi-solid state, it should not get solidify completely. In addition, there are other things which are also added. What are that? There is another agent, that is carrageenan seaweed extract is called, keeps toothpaste from hardening or separating, and glycerin which makes toothpaste form in mouth. If you remember, there gets form when you try to brush up your teeth with the help of toothpaste, then it makes form. That form, basically the glycerin is added, that leads to actually formation of foam in the mouth. And titanium dioxide is there in the toothpaste, which makes a white base and makes it opaque. So, triclosan which has been added, it inhibits bacteria and causes plaque and gum disease, that causes. So, therefore, it inhibits bacteria, triclosan. So, methyl salicylate is there just to give the flavor of wintergreen to the toothpaste. So, methyl salicylate basically is accountable for the flavor which you enjoy in the toothpaste. Right. Having said this, let us have the chemical composition of these various compounds, right. So, sorbitol is just nothing but this is a 6 member carbon compound. So, basically is a hexa hydroxyl group, hydroxyl group which has been present in sorbitol. Its molecular formula is C6H14O6 and the structure is this, and methyl salicylate is this, the methyl group substitution of salicylic acid. So, it is an ester there. So, sodium lauryl sulfate is this structure you can notice, and sodium fluorophosphate is this structure itself, the chemical structure of sodium fluorophosphate. So, this sodium lauryl sulfate is basically is just nothing but is a detergent, you must notice that. Calcium carbonate is the one which is an abrasive, which which removes plaque. This sodium lauryl sulfate is detergent which actually loosens plaque, and sodium fluorophosphate, this one basically helps prevention of tooth decay from cavities. So, these three compounds are important. Methyl salicylate is just added just to have the you can say the flavor of wintergreen. So, right, having said this, now you would have noticed what is the content of your toothpaste. Now, the question arises, nowadays very many companies are coming up with their toothpaste claiming to be the toothpastes which are based on natural extracts or which are based on natural products. For example, they say that there are a number of natural spices which they come up with, and they grind them, and then they make a paste of it, and they serve you as the toothpaste for the oral health. What is the difference between those toothpastes which are based on herbs and the toothpastes which are here the modern day toothpaste, which contains fluoride, which contains calcium carbonate, which contains sorbitol, which contain detergent? Basically the very fact is the mechanism of the two toothpastes is entirely different. The modern day present day toothpaste which are based on fluoride and detergent basically relies on the chemistry behind the synthesized chemicals, and the conventional and the toothpastes which are based on herbs and the herbal constituents, basically they relied on the action of enormous number of organic natural products on the bacterias, on plaque, and so on and so forth. So, basically that is the difference between present day toothpaste which is based on calcium carbonate, detergent, and sodium fluorophosphate base, and the others which are based on herbal plant derived solid. Right. Now, we switch on our attention to the soaps. What is a soap? We all know soaps are sodium or potassium fatty acid salts. They are produced from simple reaction, that is hydrolysis of fats in chemical reaction called saponification. Each soap molecule has a long non-polar hydrocarbon chain, sometimes called its tail, with a carboxylate polar head. So, soap is an excellent cleanser. Now, why soap is an excellent cleanser? Because of its ability to act as an emulsifying agent. An emulsifier is capable of dispersing one liquid into another immiscible liquid. Basically, the fact of matter is that soap is an emulsifying agent. More importantly, soap is biodegradable. We must understand this. Such kind of soaps which are there, we talk about, these are biodegradable. So, there is no environmental degradation out of the use of soaps which has been there. Right. Having said this, now as I said, soaps are fatty acid, long chain fatty acid salts of different fatty acids. Now, question arises from where these fatty acids do come from. These fatty acids do come from natural sources, that is plants, vegetation. These are called plant based fatty acids, which we do obtain from coconut oil, from palm kernel oil, from tallow. So, you can see lauric acid comes only from coconut oil. So, a soap which will be made out of coconut oil being used in the manufacture of soap, there you will find lauric acid salt, sodium salt of lauric acid, and you can also say sodium laurate. Having said this, now basically what is the difference? Basically we should understand lauric acid has 12 carbon atoms in it, and its molecular formula is C12H24O2, and myristic acid is basically comes from tallow and also coconut oil. So, therefore, this has molecular formula C14H28O2, and palmitic acid is basically having 16 carbon atoms in it, and that palmitic acid comes in all the three sources: palm kernel oil, coconut oil, tallow. And stearic acid, which is, you can see stearic acid and palmitic acid are the ones which are present in all these three sources. So, therefore, sodium stearate and palmitate is basically the main content of the salts which we make use of in the soaps or in the manufacture of soaps. So, oleic acid, which comes from only tallow, and linoleic acid from tallow as well as palm kernel oil. So, it depends on which natural source, the tallow, the coconut oil, the palm kernel oil, which natural source we are using. It depends which of the fatty acid salt which will be there in our soap, and that will actually be making it different, it behave differently in environment. When it comes in contact with our skin, we will also feel a difference. You must have noticed there are different soaps, they give you different texture, there are different levels of hardness also because of these long chain fatty acid carboxylates which are being present. Right. Now come over, let us discuss what is the cleansing action of soap. When we make use of soap and we try to rub it on our body, then when it comes in contact with water and forms soap, it forms foam. Basically, what occurs is that hydrocarbon chains are attached to each other of these long chain fatty acids. These are polar molecules. These are two things. One is non-polar long chain hydrocarbon chain, long hydrocarbon chain, which is non-polar, and there is a tail, there is a head. This is also the long chain hydrocarbon. Long hydrocarbon chain is also called as tail, and the carboxylate group which is being present at other end, that is called its head. So, basically what happens is that in solution, or when you get this soap applied onto your body, what happens is that the hydrocarbon chains are attached to each other and gets by way of dispersion forces and cluster together, and they form a forming structure called micelle, which is basically nothing but a sphere like structure at the molecular level with a small cavity inside. So, basically in these micelles, the carboxylate groups forms a negatively charged surface. Why? Because carboxylate groups, they are being present at the surface. So, their whole micelle is a negatively charged sphere. It will behave as if is negatively charged sphere. So, there will be so many micelles present in water, and therefore, since they are negatively charged at the surface, so all these micelles will repel each other. So, what happens when an oil or a dirt comes in contact with such water? What happens is that in such a situation, grease and oil are non-polar and insoluble in water. The fact of matter is the non-polar hydrocarbon portion of the micelle gets break up, and the non-polar oil molecule and breaks up the non-polar oil molecule. A different type of micelle then forms with non-polar soiling molecule, the oil, the dirt and dust, which gets accumulated inside the hydrophobic cavity inside the micelle. So, it gets entrapped, and with the agitating action, we can get removed in this way. We can get rid of the dust and dirt from a surface from which we want to cleanse, and that is what is the cleansing action of soap. And please make note of the fact that soaps are made only from plant based fatty acids nowadays because of the operating profits taking operating profits into consideration. Fatty acids from the animal fats is also being used these days in making soaps. So, nowadays you would also been observing certain ad films in the television which claim to be made only from fatty acid sources from plants only, no animal fats has been used, but there are others which actually do that. Right, having said so, So, it is important to note that soaps are, I said that soaps are the ones which are biodegradable. So, there is no environmental degradation upon use of soaps. So, basically when soaps were invented, they were in place, they were in use for long time. It is during World War I and II there occurred shortage of animal and vegetable fats, which were used to be which were meant to be used for saponification process and soap making. So, therefore, there was a need then to look for some other sources of fats. So, basically, or fatty acids to say, basically those ones, the answer came from crude oil. The fatty acids, you can say the wax was used to bring about making up this shortage of fatty acids from animal and plant sources, and the crude oil was, wax of crude oil was also very cheap. So, using that, another set of cleansing material was designed, that is nowadays called detergent. Basically, there is a difference between cleansing action of soap and cleansing action of detergent. Soap acts as emulsifier, it makes emulsion, that means that it try to bring up a solubility of one liquid, entrapment of one liquid into the other. You can say that what it does is it disperses one set of liquid into the other set. For example, the organic one into the inorganic polar liquid. So, basically detergents, they act differently. They primarily act as surfactants. The ability of a surfactant is to lower the surface tension of water, and when they lower the surface tension of water, then essentially makes it wetter, so that it is less likely to stick to itself and more likely to interact with oil and grease. So, that is how the cleansing action of soap and detergent is different. And basically we should understand what is the main composition of a detergent. We must understand that in soap there is only sodium salt of a fatty acid which is being present, but in a detergent there are number of two main things, you can say, although there are a number of active constituents in soap also nowadays, but two main active constituents in detergent, and in soap there is only one main active constituent. In soap there is 50%, in detergent 50% of composition by weight of detergent is sodium triphosphate as a builder. These builders are water softeners. Basically, sodium triphosphate, when is present in detergent, it try to interact with the heavy metal ions, calcium, magnesium, etc., which make water hard and forms and precipitates them. So, that is why it softens the water, which therefore can be used for the cleansing action. So, therefore, 50% of a detergent is basically a builder species, which is usually sodium triphosphate, which is being used as builder. Nowadays, because there is problem with sodium triphosphate as builder is also there, sodium triphosphate is not biodegradable and it accumulates in our aquatic areas, and aquatic areas, when it gets accumulated, there is huge pile of algae which grows on this sodium triphosphate also, and therefore which actually leads to a decrease in huge growth of green algae there at the aquatic sites, basically leads to a decrease in oxygen content of the aqueous regions. So, for example, lakes, the rivers, so, and therefore it actually leads to the endangering the aquatic life species, for example fishes, for example all other life species which are there in the aquatic, which are there as aquatic life. So, therefore, the use of this sodium triphosphate is very dangerous towards our environment, and it degrades it, and then interferes in eutrophication, and therefore it is it is a threat towards the sustainability of environment processes. Right, having said this, so nowadays these builders, instead of sodium triphosphate, they have been tried and being to be replaced with zeolites, and zeolites, there are problems with zeolites also as far as environment is concerned, but the problem is gets decreased to some extent compared to use of sodium triphosphate. The important constituent of detergent, which is actually called a detergent molecule, is in a detergent powder, is alkyl benzene sulfonates. You can see the structure of alkyl benzene sulfonates as is shown in the figure here. So, these alkyl benzene sulfonates, you can see there is these are branched long chain hydrocarbons, where there are some benzene sulfonates are being substituted over here, and therefore there are two kinds of alkyl benzene sulfonates, which are branched alkyl benzene sulfonates and the ones which are linear alkyl benzene sulfonates. Now, having said this, there is the next thing is bleaching agent which is being present. Bleaching agent, for example, sodium perborate or sodium hypochlorite, these are added to get rid of the stains which comes from cercumenides, for example, which you can say the stain coming out due to the turmeric powder or the curries which you eat, or some natural sources. For example, in blackcurrant there are certain constituents which put stains on your clothes. So, in order to get rid of them, we need some bleaching agents. So, bleaching agents are also added in detergent powder in addition to detergent molecule. So, sodium perborate or sodium hypochlorite serve the purpose, and they are being added as bleaching agents. So, bleach enhancers, they are also, in order to bring about this bleaching action to a much greater effectiveness, in order to bring about its effectiveness, we make use of tetraacetyl-ethylene-diamine as bleach enhancer also. In addition, you must have noticed there are certain stains which emerge out of sticking of some pulses, sticking of some fats or carbohydrates. In order to get rid of those kind of stains, you need enzymes to degrade the or recalcitrant stains, you can say, and which are composed of proteins, fats and carbohydrates. So, there are different enzymes to degrade the different proteins, fats or carbohydrate molecule. For example, lipases are there for proteins and proteases are for proteins, lipases for greases or oils, you can say, and amylase for carbohydrates which are being there. So, these enzymes are nowadays are also added to the detergent powder. So, they get rid you of the stains which come from proteins deposition, fats, carbohydrates, grease, etc. So, certain more additives which are added to detergent, these are which modify the forming properties of product by either stabilizing or counteracting form. And you can see there are two different kind of detergents nowadays mainly are being manufactured and marketed in the market. Ones which are meant for top loading washing machine, ones which are meant for front loading washing machine. Basically, the top loading washing machine require more water, huge amount of water, and front loading washing machine require less water, and so therefore in less water less foam should be there. So, foam stabilizers need to be added in order to bring about the forming of this detergent to a greater extent. In addition, in such front loading washing machine based detergent powders, there are linear branch chained alkyl chains, sodium alkyl benzene sulfonates are being used, and therefore, so this is just a little composition difference of front and top loading washing machine, just making it suitable to the washing machine's requirement of use of water. If there is more water is being used, even more foam gets produced, we can deal with it. If there is less water is used in a washing machine, so we need less foam producing composition. That is why this is just a little difference between front loading and top loading washing machines detergents. So, which are nowadays they are marketed in the market, you can see, and there is a huge difference in price too. and because of the different level of additions, for example, in order to counter the stains which come from protein, carbohydrates and fats, grease based. So if you want to remove them, then you need to apply those detergent powders which contains the enzymes. So obviously the cost of producing the detergent powder will increase. So you must have noticed nowadays in the market there are ad films which come up, which they claim, which they try to put in some sauces, they try to put in oils and then dry them up with the help of a iron, and then tell you that we can apply our detergent powder onto it and it can bring about cleansing, and they show you we have got rid of the stains which are from sauces, which are from dyes, which are from fats, proteins, deposit grease, etc. So this is basically all because of due to these additives which are being added to the detergents. So basically there are a number of additives which we keep on adding in a detergent. So it raises the manufacturing cost and it reflects in the cost of the product which you actually do observe in the market. For example, front loading washing machine detergent, top loading washing machines detergent, the detergents which do claim that they can get rid of different type of stains. One thing is very important, I did tell you in the beginning itself, the huge and the major component of a detergent, 50% by weight, is mainly because of the use of builders which are nothing but sodium triphosphate, which are environmentally non-biodegradable, so therefore causes risk to our environment. So we should make use of them wisely. Thank you. On this note, I would say thank you so much for your patience hearing.
With this note, thank you sir, thank you so very much. And dear friends, we believe that you might have liked today's lecture. For giving your feedback, you can mail us at info.cc@nic.in. We will be meeting again very soon. Till then, take care. Goodbye. Thank you sir, thank you so very much.